My screen is visible, right?
Yes, yes, it is visible.
Yeah. So anyone knows what is Kubernetes? So what is your definition for Kubernetes? Anyone? Okay. Let me explain. So till now, what we have learned is we learned how to create a web server and display a web page using a VM, like directly on a VM. We install web server like Nginx and HTTPD. When we learn Linux, we learned that, and we used to display the index.html page. Right. The other method was we did the same thing using Docker file. Okay. Docker file we displayed a custom image. Similarly, we were also able to display the default image which anyone else has created and kept it on Docker Hub. Okay, so these were the two methods which we have learned till now to host any website or a simple HTML app on a container and a VM. Okay. The same thing we can do using Kubernetes. Okay, but why we need Kubernetes? So we can do the same thing using containers like Docker. Then why we need Kubernetes? So in Docker, if we need one or two container, it is fine. Okay, it is easy to manage. But suppose we have many containers, like more than 10 or 20 or even 100, then it is not easy to manage all the containers. Okay, and with by default the containers will not be able to self heal means suppose it dies or it gets stopped due to some reason. Okay, we need to manually restart it. Okay, but Kubernetes, we can it has a Kubernetes has a self-healing property. Okay, so it will restart it automatically if it finds it is the container is stopped. Okay, and suppose we want to scale means we want to increase the number of containers. Okay, due to some reason, if there is a high CPU or memory load, and if you want to increase the load, okay, then that is not by default possible using Docker or containers. For that we need Kubernetes. So that's why Kubernetes is a scalable, available, and self-healing container orchestration platform. Orchestration means managing the containers. Okay, and if you see the Kubernetes logo is like this. It is like the wheel of the ship with the captain is carrying. Okay, so it resembles the same. Okay, and the captain of the ship is managing a ship. Okay, which has many containers. Similarly, Kubernetes manages many containers, or it does the orchestration of the containers. Okay, so before going deep into into Kubernetes, we need to understand two important concept. One is immutable infrastructure and the other one is declarative. Immutable infrastructure means if we have deployed something, or we have created any infrastructure. Okay, then we cannot change it. Okay, means once it is deployed, once it shouldn't be changed. That is called as immutable. Okay, and mutable means we can change it. Okay, so it is always recommended that we have an immutable infrastructure. Okay, once it is deployed, it shouldn't be altered. Okay, and what is the difference between imperative and a declarative? In imperative is a kind of a programming concept. Okay, in which we give step-by-step instructions to achieve something. That is imperative. And declarative means just achieve it anyhow. Okay, means we have to achieve this, just achieve it anyhow. That is called as a declarative approach. Okay, so by allowing the deployment of the containerized application to declarative configuration, rolling updates, version release, and the management of desired replicas, Kubernetes adheres to the concept of immutable infrastructure. So Kubernetes has both the features of declarative and immutable infrastructure. and this is nowadays becoming very famous. The infrastructure should always be immutable, and we should always use a declarative way of achieving something. Okay, so let's go deep into Kubernetes, some important concepts like what is orchestration. Okay, automating the management of containerized application is called as orchestration. So what involves in orchestration? It is the deployment of any application, scaling and management of it. Okay, so Kubernetes is not the only provider which is available in the market. So if we are means biased to Docker, then we can also use Docker Swarm. So Docker Swarm is one of the application which we can use to achieve the orchestration. Then we also have Apache Mesos. Okay, these are some of the popular container orchestration providers which are available. Okay, and what does the Kubernetes do? It helps us in achieving the scalability. Okay, the service discovery means it if there are many containers, then whatever service it is running, any container, it is easy to discover it. Okay, networking updates and other issues are automatically handled by Kubernetes. Okay, so we will be learning mini micro K8s and vanilla Kubernetes. So various providers of Kubernetes are also a Minikube, which is used for learning purpose. Micro creators, it is also used for my learning purpose. K3s is there, K0 is there, Kind is there. Kind is Kubernetes in Docker itself. Then VMware have VMware Tanzu. Okay, recently SUSE has taken over Rancher Kubernetes. Rancher Kubernetes is multi-cloud, you can say, or multi-cluster deployment of Kubernetes. Then if we are working on Google, then we have Google Kubernetes engine. If you're working on AWS, then we have EKS. If we are working on Azure, then we Azure has Azure Kubernetes services. Then for on-prem we have OpenShift, or we can also say OpenShift is available as an hybrid one. On-prem and public-private combination is also possible. Then Rancher, Anthos. There are various providers of Kubernetes, but in this class we'll be learning about vanilla Kubernetes the same way we learned about my vanilla Docker registry and micro K8s. Okay, so all the three cloud providers also have GKE, EKS, and AKS. Okay, these are the managed Kubernetes services. Managed Kubernetes services means most of the installation and infra part is handled by the cloud provider. We just need to deploy our applications. Okay, and OpenShift and Rancher, these are also very on-prem kind of an on-prem service providers or hybrid cloud providers for Kubernetes. Okay, used for multi-cluster deployments. Multi-cluster means we can have multiple cluster on-prem or also on Google, or we can say Google and AWS and Azure at the same time. Okay, so OpenShift and Rancher, these are also multi-cloud providers. Then Anthos is a multi-cloud Kubernetes provider provided by Google Cloud. So if you see this, so here I've shown this Docker. These are the containers on the ship. Okay, and this is a kind of a crane. Okay, so this crane you can consider it as a Kubernetes. Okay, what it is doing is Kubernetes. This crane is properly placing the containers based on the resources of the ship. Okay, so the Docker containers are managed by Kubernetes. So depending on the capacity or capability of the ship, okay, it places the containers. Okay, so this resembles a Kubernetes architecture. Now, if we go deep into the Kubernetes architecture, we have a master and a worker node. At least a one master node and a one worker node should be there. Okay, so some of the components of the master node. This is also asked in the interview questions. So what are the components of the master or worker nodes, or what is explain the in short architecture of Kubernetes. So the master node consists of Kube API, Kube scheduler, Kube control manager, and etcd. Okay, and the worker node consists of kubelet, kube proxy, and container runtime. Okay, so I have given a minimal explanation. So we interact with the Kubernetes using kube API. Okay, whenever we run some commands, it will first interact with the kube API, which exposes the Kubernetes API for interaction. Okay, then kube scheduler, so it assigns the pods to the nodes based on resources. So here nodes means the worker nodes. Okay, so based on the resources, the pods will be assigned to the worker node. What is a pod? In short, I'll explain pod, but in short it is nothing but a container. In terms of Kubernetes, the containers are called as pod. So the assignments of the containers based on the resources is done by kube scheduler, as the name suggests, scheduler. Then we have kube control manager in master node. It ensures the desired state matches the actual state. Means what we have defined in our declarative configuration in a YML configuration, that it will try to achieve, that is defined in a kube control manager, that is handled by kube control manager. Then we have HCD. Okay, so suppose we have defined some configuration. That configuration details in key value pairs are stored in HCD on a master node. Then we have the worker node, where actually the pod resides or pod is placed. Okay, so the kubelet manages the pod life cycle. Okay. The manages the pod life cycle means starting, stopping of the containers is done by the kubelet on a particular node. Then the kube proxy is there. It is used for network communication. Okay, the network part is handled by the kube proxy component in the worker node. Then the container runtime. Container runtime is very important. Okay, it is actually responsible for running the containers on a particular node. So Docker is one of the container runtime, but Docker is not the only one which is available in the market for container runtime. There are several other container runtimes as well. Okay, but Docker is very famous, and earlier there used to be Docker only. Okay, the same thing is explained here. So this is also available in our wiki link. Okay, but still I'll explain again. The master node consists of API server, control manager, scheduler, and etcd. Okay, then the worker node will have kubelet, kube proxy, and container runtime. Now let's learn some important concepts. Okay, so pod is nothing but a container, but it can be one or more than containers. So pod is a group of containers. Okay, why there is a requirement for group of containers will soon come to know. Okay, so pod is smallest deployable unit containing one or more containers. Okay, then we have various types of controllers which handle the deployment, replication, and all. Okay, so various controllers are there. So whenever we deploy a pod, if you want its replica, then the replication controller will help us. So these are the internal components. We cannot directly interact with the control. We do not see the controllers. These are already installed, but we should know as the definition for it. Okay, so for containers, if we want the replication, that is, we want exact copy of it, the number of copies, that is handled by replication controller. Okay, then its improved version is replica set. And if you want to deploy application, then deployment controller will be used. Okay, so deployment manages the pod lifecycle and updates. We'll see by tomorrow how to deploy any application. Then we have stateful applications. Okay, for the time being, just ignore it. Stateful and stateless, these are the two types of applications which we can deploy. And in Kubernetes, everything is accessing the application on a Kubernetes cluster is done by various services. Okay, so there is a cluster IP, node port, load balancer, and ingress. These are the ways to access the pod or a container. We'll be seeing this. We'll be seeing this soon in detail. Then we have config map and secrets. So whatever configuration data we need for application, that will be stored in config maps, and sometimes we also need to store the secrets. Okay, we cannot say, put everything in a YML configuration in a clear text format. There will be using the secrets. Okay, then today we have a lot of theory. And when we learn about Kubernetes, we need to learn about some important concepts. Okay, so there are some group of standards. Okay, for containers which are defined. Okay, in the you can say in a Kubernetes community or CNCF, Cloud Native Foundation. Okay, they have come up with some standards. So one of them is OCI. Okay, Open Container Initiative. These are the standards for containers. Okay, that are useful for distribution, runtime, and image format. Means how the container will be distributed, how it will run, what should be the image format. Okay, that is defined in OCI. These are some standards. Then for container runtimes. Okay, so for usage of various container runtimes, CRI is defined. Okay, container runtime interface. So why there was a need for these standards? Okay, and Docker plays an important role in maintaining these standards. Okay, there are some other companies also. So all these companies have come together to agree on some standards, so that nobody comes up with their own standard and manipulates or try to means what we can say. Means there shouldn't be any single vendor dependency. Okay, so everyone should follow some standards. The same way we find IPv4 and IPv6 protocols, right? So that everyone adheres to those protocols. Similarly, for Kubernetes, we have OCI and CRI uh, standards. So OCI standards, the Docker, Containerd, CRI-O. Okay, so these are the runtimes. Okay, so Docker is one of the runtime, Containerd is another runtime, and CRI-O is the another runtime. They all are following the Open Container Initiative. Okay, the Kubernetes, Docker, Shim, CRI-O. These are following CRI interface, and there are some other OCI compliant runtimes like Runc, Katacoda, Rancher OS. Okay, so these are some of the standards. Okay, and uh, though this is not directly related to Kubernetes, but we till now we learned about the Docker. Okay, but we used to say that the Docker is running the containers, but it also has some low level components. Okay, so whenever we run the Docker command, it calls the containerd. Okay, the low level component, or you can say the high level component, containerd. Okay, which is responsible for image handling and networking. So whenever we run the Docker command, the containerd component gets activated. Okay, which is responsible for pulling the image and networking storage. Okay, and it in turns gives the request to runc, which is the low level container component. Okay, in a Docker stack. Okay, which does nothing but create and run the containerized process. Okay. So Docker is nothing but a combination of containerd and runc. Containerd is a high level component and runc is the low level. So what are the benefits of Kubernetes? So earlier also I have explained, due to some reason, if the pod or a container is stopped, it will self heal by restarting, rescheduling, or replacing. So auto healing is one of the feature of Kubernetes. Scalability, that is uh, scale up when there is a high load, and scale down when the load is stabilized. That is, auto scaling is also possible using Kubernetes. Auto healing, auto scaling, rollout and rollbacks. Rollout means deploying the application, and rollout means due to some reason if the deployed application is not functioning properly, then we can roll it back. Service discovery, if there are many number of containers, then various services will be there for those containers. Kubernetes makes it easy to discover those services. Then the orchestration. Okay, storage orchestration, then we can easily manage the secrets and configuration. For batch and CI workloads it is useful. Okay, and bin packing, automatic scheduling based on resources and constraint. These are some of the benefits of Kubernetes, but I find that auto healing and auto scaling, these are the two important benefits of Kubernetes. Okay, so there are some limitations on number of pods and nodes. Okay, so this is also given in the wiki link. If you are interested, you can learn. So not more than 110 pods per node, not more than 5,000 nodes. Okay, not more than this number of total pods can be there, not more than this number of containers can be created. This link is also there. Okay, if you want, it is given in the wiki. Okay, so now we will start the installation part of the micro K8s. But before starting the micro K8s installation, if you have any questions, let me know.